This will be my first recording on the topic circle theorems. There will be a few videos, but we'll start with these 4 circle theorems as these are the easiest. So we're going to start with the circle theorem. The angle in a semicircle is 90 degrees. Here, we're looking for a diameter within a triangle within your circle. And if you see that triangle with the diameter, the corner is always 90 degrees. So if you see in this first question here, we have a diameter. So this has to be 90 degrees. What's our missing angle? 180, take away 90, take away 65, which is 25 degrees. Okay, next one. So here we've got 2 diameters, as you can see here. Well, it's not one diameter, but 2 triangles, sorry. Here's my first triangle that I'm going to be looking at. I know this here is 90 degrees. 180, take away 90, take away 28, gives you 62 degrees for X. And then for this bottom triangle here, diameter, triangle, this corner here is 90 degrees. 180, take away 90, take away 44, gives you Y is 46 degrees. Okay, for question 3. If you can see, we've got the diameter here. So we know this corner is 90 degrees. Okay, another point with circle theorems. Now, this is not a theorem, but I always look out for isosceles triangles. So isosceles triangles are created when we have 2 lengths the same size. So you have a radius there, and you have a radius there. Obviously, any radii in a circle are going to be the same length. So can you see we do have an isosceles triangle. For an isosceles triangle, the base angles are the same. So we've got Y is 55 degrees. Now we know that Y is 55 degrees. We've got a triangle here on the left-hand side. Angles in a triangle add up to 180. So we have 55 add 55 is 110. Take off 180 gives you X is 70 degrees. And then you've got for Z, can you see that X and Z lie next to each other in a straight line? So Z is 110 because X is 70, 180, take away 70 gives you 110. Okay, these are all based on the theorem. The angle in semicircle is 90 degrees. So there's our semicircle. So have a go at these 3. Put me on pause, see how you get on. Okay, so this first one, you've got X is 18 degrees. Now for this second one, we're looking out for the isosceles triangles again. So that length is the same as that length. So those 2 angles are the same. Don't know any of those yet, but we do know that this length is the same as this length too. Got an isosceles triangle here, so Z is 22. Can you see here? We have the diameter. So we know we've got angles in the semicircle. We know we've got to use this theorem. This corner here is 90 degrees. The 90 take away 22 gives you X is 68 degrees. And we've got an isosceles triangle here as well. So X is 68. This is also 68. 180, take away 68, take away 68 gives you Y is 44 degrees. And again, we've got 2 triangles made from this diameter. We've got this is 90 degrees. So it gives us x is 180, take away 90, take away 31, 59. And then on the other side, we've had the two lengths are marked as an isosceles triangle here. And we've got the diameter, which means this is 90. So these angles are the same here. 180 take away 90 divided by 2 gives you y is 45 degrees. So that's our first theorem. Let's look at the second one. So for the second one, angles in the same segment are equal. So I always look out for this bow shape. Look out for a bow shape. All corners of your bow touch the outside the circumference of your circle. So these two angles are the same and the bottom two angles are the same. So for this one here, these two angles are the same, so x is 50. And for this one here, this time, if you can see, there's a couple of bows going on here. I'll be zoning in on that one there. These two angles are the same, x is 52. Here's my bow. X is the same as this. What is that angle? We have got a triangle on the left-hand side. 180, take away 88, take away 27 gives us this angle here is 65, which is the same as this angle, so x is 65 degrees. Okay, have a go at these three yourself. Put me on pause and see how you get on. First one, x is 24. The second one, so this bow's kind of been turned around here, if you can see. So it's like the tops of the bows that are the same. Can you see that x is 38? And for your angle fact for y, opposite angles are the same, so y is 95. And well done if you've spotted theorem 1 is also involved in here as well, because we have a diameter too. So you've got a diameter, so we know that's a right angle. But let's just look, right, so we've got the bow here. Let me do that one first, which tells us that this is 35, so this is 35. What next? So we know that's a right angle, don't we? Because this is a diameter. And now we've got the triangle with the diameter with our 90 degrees, 180, take away 90, take away 35, gives us this x angle here is 55 degrees. Okay, so next we're going to look at this. It kind of looks a bit like an arrow to me. And it's the angle at the circumference is half of the angle at the centre. So that's the angle at the centre, and that's double the angle at the circumference. So angle at centre is double the angle at the circumference. Double 51, we get 102 degrees for x. Okay, for this one, the angle at the circumference is half of the angle at the centre. Half of 165 gives you x is 82.5. Now, this one is a little bit more tricky to spot because it doesn't really look like the diagram too much. A lot of people think this is the bow theorem. This is not the bow theorem because all the corners of your bow touch the outside the circumference of your circle. Here they don't. So this, I call this the arrow disguised as the bow. But it's not the bow because that is not on the outside. So can you actually see its angles at the centre is double the angle at the circumference. So double 45 is 90 degrees. So just watch out for that one. So the top tips at this point here are look out for any isosceles triangles and look out for the arrow disguised as the bow. Okay, so have a go at these. Put me on pause and pause when you're done. Okay, for this top one, you should have got x is 61 because it's half of 122. For this one, we've got the angle at the circumference, we need to double it to get 76 for the angle at the centre. Here we need to halve this 194, which gives you 97. And here we do have the bow disguised as the arrow. The angle at the centre is double the angle at the circumference. So we just need to halve the 87, which gives us 43.5. And the last one that we will be looking at today for this recording is the cyclic quad theorem. If you ever see a four-sided shape inside your circle, the opposite angles add to 180. Okay, so for this one, x is 180 take away 97, which is 83. And then for this one here, y is 180 take away 76, which is 104 degrees. And for this one here, so we might want to highlight around your quad. There's my quad. I can see that theorem here. So let's get that angle there. 180, take away 46 gives you 134. And then can you see we've got angles in a triangle. We've got this bottom triangle here. 180, take away 134, take away 23 gives you x is 23. Oh, it is actually an isosceles triangle too. This one here. So let's do I can spot the arrow theorem here. The angle at the centre is double the angle at the circumference. So x is 72. Now just be careful with this. A lot of people then do, well, this is 180 take away 72 because I can see this quadrilateral here, but it's not, you cannot use the cyclic quad theorem for this because all your corners don't touch the outside. It's this, here's your cyclic quad because all the corners touch the circumference of your circle. So for y, it's actually 180 take away 36, which is 144 for your y here. Okay, have a go at these three, see how you get on. 180 take away at 50 is 130 there. And for y, these add up to 180, 95. So for this here, you should have spotted you have your cyclic quadrilateral here. 180 take away 140 gives you 40 here. Angles in a triangle add up to 180, which gives you x is 68. Got the arrow theorem here, as you can see. So x is half of 150, which is 75. And then you've got your cyclic quad is here. 180, take away 75. 105. Okay, so now look out for my other recordings on circle theorems and maybe have a go at the more complicated ones next.